rational functions. Objective: by this lesson you should be able to graph a reciprocal function and graph a rational function. So before this, we did linear and quadratic functions, which are the first members of a family called polynomial functions. Polynomial functions are any function that can be written in this form, right? So you just have like linear terms, quadratic terms. You have x to any power you want. No fractions, nothing else. It's just like stuff like 3x to the 4th plus 2x minus 1. These are all called polynomial functions. Now when you get a polynomial function divided by another polynomial function, we get what's called a rational function. So you could get stuff like y equals 3x to the 4th plus 2x minus 1 divided by x minus 2. Rational function. Now we're going to start off graphing the very most basic rational function, which is also known as a reciprocal function. So it's just some number over x, right? So it's this is a constant polynomial over a linear polynomial. This is called a reciprocal function. And the most basic form of that is 1 over x, and that's what the graph looks like here, right? How do you get that? Well, if you just do an over table, let's say we do negative 2, negative 1, 0, 1, 2. I'm going to type it into 1 over x. Well, negative 2 into that is negative 1/2. So, negative 2, negative 1/2. Around here somewhere. Plug in negative 1. Negative 1 over negative 1 is negative 1. So that's where you get the point right here. If you try to type in 0, 1 over 0 is undefined. That's why you see no values here at 0. So undefined right here. 1 over 1 is 1, and then 1 over 2 is 1/2. So you get 1 over 1, and then 2 and 1/2. See, the graph looks like this. So it's a reciprocal function. A couple key things with reciprocal functions, or actually any rational function, is a vertical asymptote and a horizontal asymptote. Let's talk about the vertical asymptote first. So that's a line you cannot cross. Vertical asymptote becomes the fact that that's where your graph is undefined. So it's a line that has shed no value. So we call it a vertical asymptote. It's a line you can't cross. The way you find a vertical asymptote, very simple, never changes. You set the denominator equal to 0. So in this case, you get 1 over x, you set x equal to 0, and you get a vertical asymptote. That actually leads to our domain also. Our domain, well, the only value you can't be is the vertical asymptote, so domain is just x not equal to 0. It's everything except for 0. Now the horizontal asymptote is actually slightly different. You actually could cross it, it doesn't tell you that. Horizontal asymptote, all it tells you what happens at the end points. So it lets you know what's happening as you go into infinity. That's what horizontal asymptote tells you. It lets you know, oh, as you go into infinity, your graph should be hitting this number. Or as you go negative, your graph should be hitting this number. The way you find a horizontal asymptote is a little more complicated. Look at the powers. If the top power is bigger than the bottom power, then there's, well, for the sake of IB, there's none. No horizontal asymptote. If the power is different by 1, it's actually called a slant asymptote, but we're not going to cover that in this class. If the bottom power is greater than the top power, we have it at y equals 0. And if they're the same, we have the ratio of the coefficients, and we'll talk about that more later. So if we're going to problem here, 1 over x, the bottom power is bigger, it has the power of x to the first. This has no power on top, so the bottom power is bigger. So our horizontal asymptote is at y equals 0, which is why we got the line right there. It actually has to do with the range. If we look at the range of the graph, range is the y value, so the only value you see that's not taken is what our horizontal asymptote is, so it's just y cannot equal 0. So those are the basic rules of a rational function. If you want to find the denominator, so if you want to find the vertical asymptote, so the denominator equals 0. If you want to find the horizontal asymptote, look at the powers. Top bigger than bottom is none. Bottom bigger than top is 0. And if the bottom equals the top is the ratio. So let's do an example. Consider the function 6 over x minus 2 plus 4. Find the asymptotes of the function. Okay, so for A, we're going to find the vertical asymptote. Or all we do there is set the denominator equal to 0. So x minus 2 equals 0. We solve it. X equals 2 is our vertical asymptote. Now we want to find the horizontal asymptote. Remember, now we look at the powers. So what power is bigger, top or bottom? In this case, the bottom has a power of 1, top has no power, so bottom is bigger than top. So y equals 0 again. Now there's one difference with this one. It is 0 from this, but there's a plus 4 on the side. So it's actually, horizontal asymptote is actually 0 plus 4. So y equals 4 is my horizontal asymptote for this one. Find the x-intercepts. Now we should always know how to find this. We can do this with any problem they ask us. Any graph, you should always be able to find the x-intercept. So if you want to find the x-intercept, you set y equal to 0. So we're going to go 0 equals 6 x minus 2 plus 4. And we just have a math problem. Let's subtract 4 from both sides. Put over 1. I'll probably cross multiply here. And get negative 4 x minus 2 times 6. Right? So multiply these two, multiply those two. Distribute. Negative 4x plus 8 equals 6. Do a little math. Negative 4x equals, subtract 8 from both sides. Negative 2 divided by negative 4. X equals 1/2. So 1/2 and 0 is my x-intercept. It's a lot of work. I'm going to have to erase that in a bit. But that's how you always find the x-intercept of any function, any graph, right? Set y equals 0. If we want to find our y-intercept, we set x equals 0. It's usually the easier version of that. So we're going to set y equals 6 over 0 minus 2 plus 4. So we get 6 over negative 2 plus 4. So I get negative 3 plus 4, which is 1. So the point 0, 1 is my x-intercept. My y-intercept, sorry. You said how you help graph sketch a function. We actually don't need to use technology for that. We have everything we need. So let's graph this function. So when I graph a function like this, the first thing I do is start with the asymptotes. You want to plot those guys. I'll do them in red. We don't have enough red. I'll do in green. So you want to graph the asymptote. So x equals 2. So go to 2 in your x. Draw a vertical tally mark. And then we have over here y equals 4. So 1, 3, 4. Draw a vertical tally mark. Now the way this graph works, you can only have one on each side of the x. So it's going to be up here, or it's going to be down here, or it's going to be up here and down there. General rule is, if the number on top is positive, it should be on the top right and then bottom left, as you see it from up here. Right to 1, so top right, bottom left. If it's a negative one, you flip it. It'll be bottom right, top left. So I should already know this one's going to go up here and down here. Now let me erase some of this because I need the space. There we go. Let me not forget with the x-intercept, y-intercept, which is 0, 1. Okay. Now, first of all, I actually have a little more information. I have the y-intercept and the x-intercept, so let's plot those. 0, 1, and 1/2, 0. So right here. As you can tell from here, my graphs can kind of go like this, right? Like I said, bottom left, because it's positive 6 on top. And then keep in mind, you should not go past either asymptotes. You should get really close to them. So it's going to look kind of like this. Gets really close whenever it goes past, and the same thing down here. Gets really close whenever it goes past. Now, if you're not sure about this, which way does it go in here? You could use your calculator, plug it in if they let you. You can also just plug in a point and see where it goes. So if I plug in the point, like let's say 4, into this equation up here, let's see what we get. We get 6 over 4 minus 2 plus 4. So I get 6 over 2 plus 4, 3 plus 2, which is 5. So it'll be the point 4 and 5, which is up here. So my graph is on this side. And again, I should not go past the asymptotes. I actually don't like this one. Should be a little more straight. Should not go past the asymptotes. So like that. But again, I knew it was going to look like this because the top was a positive. So top right, positive, top right, bottom left. So that's one way you could do it. So you either know it's positive, so top right, bottom left, or it not only works with a reciprocal function like this, use your technology or plug in points. Those are the ways to tell which way it goes. Next one here. So we're going to do this example. Find the equation of asymptotes. So again, that's easy. Vertical asymptote, denominator equal to 0. X plus 1 equals 0. So x equals negative 1. Horizontal asymptotes. And with the powers, again, bottom power is bigger than top power. So that's 0. But we have a 2 right there. So it's kind of, this one's going to be 2 minus bottom bigger than top, which is 0. So I just get 2. So this is my vertical horizontal asymptote. Say the domain and range. Very simple. If you want the domain and range, domain is just the vertical asymptote. X cannot equal negative 1, right? That's the one thing you can't be. And the range is going to be the horizontal asymptote, but you just can't be that value. So y cannot equal 2. There we go. Number 3, find the axis intercepts. So we're going to find the y-intercept. Set x equal to 0. So we're going to get y equals 2 minus 3, 0 plus 1, which gets me 2 minus 3, which is negative 1. So the point 0, negative 1. If I want to find the x-intercept, we're going to plug in y equals 0. So we're going to get 0 equals 2 minus 3 over x plus 1. Move it over, 3 over x plus 1 equals 2. Cross multiply, I get 2x plus 2 equals 3. It's giving a little bit of steps here, but it's when I get there fast. So 1/2 again. So 1/2 and 0. And now they want me to sketch the graph. So all we're going to do is sketch the graph. Always start off with the asymptotes. So x equals negative 1. And then y equals 2. So 1, 2. Now, right, if we're just doing a quick sketch of it, is it going to be top right and bottom left, or is it going to be flipped? This is a negative. Look where the x is. This is a negative value. So it's actually going to be, should be bottom right and top left because it's a negative value. And you can tell that by the y-intercept. Right, 0, negative 1. So right here. And my x-intercept is 1/2. So it's right here. So it's something like this. And then if it's down here, it should be up here since it's a basic rational function. Well, if you want to check that, you put in your calculator, or you can plug in a point. Plug in a point like -5 and see what you get. But there's that problem. Okay, let's move on to a more rational function where there's an x on both top and bottom. So the first thing with this, the positive top right, bottom left thing, not going to work anymore. That only works for reciprocal functions. So when it's super basic, that's when you know you could go, okay, I can do a little shortcut. If it's positive, top right, bottom left. If it's negative, bottom right, top left. It doesn't work for when there's an x on both top and bottom, but the rest of it does. So let's do this anyway. So A, find the vertical asymptote of the function. So all we have to do is the denominator equal to 0. X equals 1. B, find the x-intercepts. So we have to find the x-intercept and the y-intercept. So x-intercept, we're going to say y equal to 0. So we're just plugging 0 for y. So we get 0 equals 2x plus 1 over x minus 1. Now look what happens here if you try to cross multiply, which I mean we're going to cross multiply, you don't have to try. You get 0 equals that. These actually cancel out. All you get is 0 equals 2x plus 1. So subtract 1, 5 by 2. X equals negative 1/2. So negative 1/2 and 0 is my x-intercept. Y-intercept, sorry, I hate when that happens. Y-intercept, plug in x equals 0. So we're just plugging into the function, sub it into the function, 2 over 0 plus 1, 0 minus 1. I get 1 over negative 1, which is negative 1. So 0, negative 1. So there's my y-intercept, there's my x-intercept. Next, rearrange the function to find that horizontal asymptote. Now we do not need to do that. If you want to find the horizontal asymptote, we know how to find it. Look at the powers. Right, and then what happens here? They're both the same. So in this case it's the ratio, top equals bottom, which was y equals the ratio. So what does that mean? We look at the coefficients of the highest power, 2x and x, and we take the ratio of it. So y is an equal 2x over x, also known as y equals 2. That's horizontal asymptote. Super simple. So if they're ever the same, just look at the ratio. So in this case, 2 over 1. Okay, horizontal asymptote done. Draw a sign diagram. We don't do that. You don't need to. Discuss the behavior of the function of asymptotes. That's just a horizontal asymptote. They're going to get close to 2. Sketch the graph of the function. So let's sketch this graph. Here's x, here's y. Right, first thing we always do is plot the asymptotes. Then we fill it in from there. So I have an asymptote at x equals 1. So here's my x, here's 1. And I have an asymptote at y equals 2. Now remember what I said before, we can't just go, oh, it's positive, because it's not positive. There's a variable there. I have no idea what the top is. So I can't just go top, right, bottom, left. All rules are off in this case. So what do? Well, we plot our x and y intercepts and see where that helps, where that takes us. So we have negative 1 and 0. Negative 1/2 and 0 right there. And we have 0 and negative 1. So right here. So we know for sure, right, because it has to be a function, so it can't be up here and down here. It has to only be down here. So like that. Now, how to figure out what happens on this side? Well, two choices. Put in your calculator and graph it, or just sub in a point. Do a little test point. Let's try the point here at, this is what, 2? Let's sub in 2 into the equation. If you get a number above 2, it's going to be on the top. If you get a number less than 2, on the bottom. So that's one way to try it. So we're going to do f of 2. I'm going to get 2 times 2 plus 1, or 2 minus 1. So I get 5 over 1, so 5. So at 2, I should be at 5 up here. That lets me know my graph should be going like this. Notice that the sketch isn't perfect. But there we go. There's my graph. And if you want to use a calculator, you could. Gotta turn it on first. Right, there we go. So you go to y equals. I'm going to type in my equation, 2x plus 1 over x minus 1. Now remember, it is a fraction, so you either have to put parentheses around top and bottom, or alpha y equals, and type 2x plus 1 over x minus 1. Oops. What is it there? It should be down. It should be over here. X minus 1. Hit graph. Make sure my zoom is normal. Something like that. Now you notice most calculators do not drop the asymptotes. And if they do, it looks disgusting. You do the asymptotes yourself, and you can always fill it in with your calculator if you need to. Now, if you don't get to use a calculator, you can always type in a point yourself, like I did here. Anyway, that's the lesson.